To get a stable pattern of observable interference fringes, matching waves and a stable environment is needed. So we'll have coherent light sources, which means they have the same frequency and a constant phase difference. If these waves are light waves and we place a flat screen in their path, we will see a diffraction pattern. Where two lines meet at the screen, the constructive interference means there will be a bright line, a bright fringe. We get one right in the center, and then they are positioned away from there. Halfway between two bright fringes, we can see that one line, a maximum, lies exactly between two lines from the other slit, which must be a minimum. And this produces destructive interference and a dark fringe. Now we have two waves coming from two slits traveling to superpose at a point on the screen. Suppose they both leave the slit at a maximum and both reach the screen at a maximum. They must have both travelled an integer number of wavelengths for this to be true. If wave 1 travelled a distance of n wavelengths, wave 2 must have travelled n plus 1 or n plus 2 or n plus m wavelengths. In other words, wave 2 travelled an integer number of wavelengths further than wave 1. This is called the path difference. So path difference is the difference in path length that two waves took to reach a point. Now, if the path difference is n lambda, the waves will be in phase when they reach the screen, so there is constructive interference. Whereas if the path difference is n half lambda, the waves are out of phase when they reach the screen, so there is destructive interference.